All right, we're going to start some relative velocity questions. A boat with the ability to move at 10 meters per second in any direction points directly across a 100-meter wide river with a current of 5 meters per second. And we want to know how long it takes to cross. Well, let's draw it really quickly. Not that it's a perfect drawing, but let's say we've got the 100-meter wide river. Put in that 5 meter per second current. Now, if the boat points across with 10 meters per second, what we're saying is that 5 meters per second current doesn't affect that 10 meters per second. The boat will cross in a line like this, and it will have a resultant velocity pointing in that direction. So the current does have an effect on the path that the boat takes, but as far as the boat going across in this y direction is concerned, the current doesn't change that at all. It's still going 10 meters per second this way. It just now happens to have a 5 meter per second velocity in the other way. So looking at crossing the river, that's just a y direction as drawn. Question. In the y direction, we have a velocity of 10 meters per second. And if the river is 100 meters wide, then our change in y is 100 meters. So finding the time in the y direction, if we look at velocity is the change in y over time, multiply both sides by time, time goes away. Now we have t times v is equal to the change in velocity. Well, then our time is just going to be the change in y over the velocity, or 100 meters divided by 10 meters per second, giving me a time of 10 seconds. It's going to take 10 seconds to cross that river because it's just a y direction thing. Now, other stuff is happening in that 10 seconds. Looking at it, we're also going at 5 meters per second. So if we ask how far downstream, does the boat drift? Well, then we're going to have to take into account that 5 meters per second, because at the same time, we were going across at 10, we're being pushed downstream at 5. This becomes the boat. This becomes an x direction question. And in the x direction, I have the velocity of the current. That's 5 meters per second. And I know that I'm going at that speed, 5 meters per second, for 10 seconds because I'm in the water that long. So my delta x is just going to be, from the same equation up there, velocity times time, or 5 meters per second times 10 seconds. My delta x comes out to be 50 meters. Okay? Now, that leads us to another question, which is, get straight. What is the resultant displacement? I want to find out how far he went total. Well, we went obviously the 100 meters across the stream, and now we want to know about the 50 meters in this direction. So our resultant displacement is going to be the square root of 100 squared plus 50 squared, giving me a resultant displacement of 111.8 meters. And if we want to find this angle, the tangent of that angle is equal to 50 over 100. That angle comes out to be at 26.6 degrees. And looking at that, we start off north and we go east from there. So it's east of north. Now, We're done with that part of the problem. That's how far we went total. So it was more than just the 100 meters, and it was more than just drifting down the stream. 50 meters. The next question we're going to want to look at with this same set of information, so we'll start back up here, is what is the resultant velocity? Now we have two different ways we can look at that. Way one is to say that our resultant velocity is equal to our resultant displacement over the time. Well, that's the easiest one. Our resultant displacement was 111.8 meters. Our time was 10 seconds, so our resultant velocity is 11.2, I guess if we round, meters per second at the same angle, 26.6 degrees east of north. That's one way of doing it. The other way of doing that is looking at the components of our velocity. We had 10 meters per second to the north. We had 5 meters per second to the east. So if we look at our resultant velocity, it's the hypotenuse of that triangle, square root of 10 squared plus 5 squared, which comes out to be, lo and behold, 11.2 meters per second. If we wanted to find that angle, the tangent of the angle would be 5 over 10, so that angle would come out to be 26.6 degrees east of north. We have two different things. What happened is that the river added to the velocity of the boat, but because they were at 90 degrees to each other, it added to it vectorially. So we had to find that hypotenuse, but it works out the same all the way through.